All right, I've got 4 o'clock on my watch. So let's go ahead and get started. I'm going to wrap up Code PaLOusa for you this afternoon. I thank you guys for coming out, and hopefully this information is helpful. It's been very thought-provoking for me as I've prepared for this and as I've read and studied and researched. And so hopefully some of what I've learned is meaningful to you, and I can communicate that. We'll start out here by thanking our sponsors. There we go. So thanks to Amazon and Andromeda and Modus and Software Guild for sticking with Code PaLOusa and the changes they've made. Certainly appreciate their willingness to try out this little experiment and try and make this event great, even though it's the first time we're doing it online. I've thought the event has worked really well, so thanks to them for being willing to try the experiment and support it. What I want to talk about today is the importance of understanding your limitations. And I don't mean the limitations of your tools. I'm not talking about the limitations of your software. I am specifically talking about the limits on the CPU inside of your head. Yeah, that's right. We're going to talk about the often flawed computer that is your brain. And we will look at why a lot of recent scholarship has pointed at that being a key piece of creativity, of learning, and collaboration. It seems like a million years ago that we had news in this country that was about something other than COVID or political or racial unrest. But there was a time earlier this year when the big news was the relatively terrible quality of the Iowa Democratic Caucus software app. And it was news, it was politically important. But the fact that we had a piece of software that didn't function the way that it should or at all wasn't really that surprising to a lot of people. We are somewhat used to our software being flawed. And this does have negative ramifications for our broader society. Knock on wood, we won't have any software issues in the election this fall. And the issues they had with the app in Iowa this year maybe didn't change the outcome of things much. So, thank goodness for that. But we do have this broader problem of systemic software issues. And this is not a new thing. This is actually something that has been going on since like the 1960s. The first time anyone ever uttered the phrase software crisis was in the 1960s. And that leads us to the work of this man. His name was Edgar Dijkstra. If you've not read about his work or his resume, you're kind of missing out. He was a brilliant pioneer of the software industry. He was very instrumental in the development of things like programming languages and operating systems, and especially distributed systems. And in 1972, he was awarded with the ACM's highest prize, the Turing Award, often considered the Nobel Prize of computer science. And in his acceptance speech, he chose to talk about the software crisis. And you might think with all of the work that he had done on languages or tooling or operating systems that maybe what he really would want is better software. But the solution that he advocated was for software developers to have a more realistic approach to their own abilities. His paper, his acceptance speech, was called The Humble Programmer. And I'll highlight one of the key passages here. Dijkstra says, The analysis of the influence that programming languages have on the thinking habits of its users, and the recognition that by now brain power is by far our scarcest resource. They together give us a new collection of yardsticks for comparing the relative merits of various programming languages. The competent programmer is fully aware of the strictly limited size of his own skull and therefore approaches the programming task in full humility. And among other things, he avoids clever tricks like the plague. It was reading this paper that actually kind of got me down this road, or got me started down this road of researching things like intellectual humility. If Dijkstra thought that this was one of the key components to successful software development, then certainly other people have written about it and have verified his approach. So let's start a little bit by talking about what we mean by humility, because humility, as it's generally maybe commonly used in English, is often kind of used in some kind of like self-deprecating term. You might say someone is humble when maybe they don't have real high self-esteem. And that's not what we're talking about here. Humility is not self-deprecation. And I certainly am not advocating for imposter syndrome, or I'm not trying to impose some kind of intellectual gatekeeping. I want to bring more people into the field. And there are a lot of people that are very good developers. What I hopefully can show you through some of the research we'll look at today is that for everyone that comes into this field, the way that they can learn and grow and advance in their skill set is to be humble. We're not trying to kick people out. We want to help them learn. The other thing that is often misunderstood about humility is that we associate it with spinelessness. Being humble doesn't mean that you're just going to let people run over you. You can have opinions. You can stand up for your values, for what you believe to be true, but still be humble. One of the things that's really interesting, and you can go back in Dijkstra's paper and read more of the context for this, but he says that brain power is by far our scarcest resource. Right before he says this, he has talked about how incredibly powerful computers have become. So let's rewind a little bit of history here. Dijkstra had started in software development like in the 1950s. And so he had seen over 20 years just an unbelievable amount of growth and how powerful computers had become. But let's stop and remember that this was 1972. In 1972, the most popular video game, maybe the only video game released, was Pong. Yep. Look at those sweet graphics, right? This was the state of the art. This was what Dijkstra was talking about. He was talking about how incredibly powerful our computers were. Also, the most powerful processor that came out that year was the Intel 8008. Sweet little processor for the time, very powerful, very cost-effective for the time, but almost nothing by our standards. A very underpowered processor by modern equivalents. So when he says brain power is by far our scarcest resource, just think about how much more true that is now. Our CPUs and our GPUs, our internet connections are almost infinitely more capable. And so the things that our computers can do has grown. What we can achieve, maybe not so much. He goes on to say that the competent programmer is fully aware of the strictly limited size of his own skull, and therefore he approaches the programming task in full humility. One of the things that I really want to emphasize here is that humility is not thinking less of yourself than you should. Humility is having an accurate view of yourself. Humility means that we have an accurate understanding of our own cognitive biases, of our own limitations in memory, of our own limitations and experience, and appreciating that other people around us might have ideas that are as good or better than ours, and being willing to admit that we are very prone to mistakes. Dijkstra goes on to say that the best way to learn with our limitations is to know them. So again, there's almost like this Socratic or Confucian idea of knowing yourself. This idea that we need to understand what we're capable of and not capable of. But he goes on to say, by the time that we are sufficiently modest to try factored solutions only, because the other efforts escape our intellectual grip, we shall do our utmost to avoid all those interfaces, impairing our ability to factor the system in a helpful way. I've been fascinated by this statement for a long time, because abstraction in software development is something that we can get right, but it's also something we can get wrong in both directions. We can have solutions that have too much complexity and are hard to understand because maybe there's too many layers of abstraction. A lot of times we refer to this as lasagna code, where they're just layers on top of layers on top of layers, and you can never really understand anything. If we have too little abstraction, we call that spaghetti code, because everything is kind of intertwined and wound together, and it's hard to understand because you are making these jumps from different layers of abstraction all right in the same function. And so what Dijkstra is advocating here is for a properly factored solution. When we have properly factored solutions, we can reason about the business logic without reasoning about our database calls at the same time. We can reason about how to optimize something in the back end without re-architecting the front end. When we have proper separation of concerns, what we can do is we can solve problems in a narrow area. We have to realize that we are not capable of keeping every single detail of a large software system in our head. That's why we have to use abstraction and separation of concerns to make the individual components reasonable. When we think about the cognitive biases or the mental mistakes that we're capable of making, what this leads us to do is to admit the possibility of personal error. That should lead us to things like better testing. If I am willing to acknowledge that maybe I made a mistake, even a simple mistake, then I will have testing in place to check myself. And maybe that's automated tests, maybe that's manual tests, maybe that's QA test. Hopefully it's some combination of all those things. But as a humble developer, I will realize the need for those and recognize the importance of those. When I admit that there's a possibility that I made a mistake, it will give me more value out of my code reviews, because I'm not going to go into a code review thinking that my idea is the best. I'm going to go into the code review admitting that someone else might have a good idea, a better idea than I had. And that doesn't necessarily make them better than me. It just means that their idea is better than mine. It also helps us ask for assistance appropriately. When I let my ego get in the way of collaboration, I can get stuck on a problem for much longer than I need to. When I am willing to admit that I make mistakes, that means that I'm willing to go to my teammates, to my collaborators, and ask for help. What's difficult for a lot of developers, myself included, is that a lot of times we don't want to go to less experienced developers and ask for help. I have to put my ego in check and say that even though I've got roughly 20 years of experience, there might be someone with 6 months of experience that has some knowledge in a specific area that I don't have. Maybe there is something that because of their education or just their work experience, that in a limited amount of time, they have learned more about this topic than I have. And that's okay. That's not like a strike against me, but I have to be willing to admit that. Another thing that admitting the possibility of personal error leads to is better naming and documentation. There's an old Chinese proverb that says the faintest ink is stronger than the most vivid memory. And one of the things that we have to admit is that our memories are not perfect. And so when I'm writing software, there may be things about that software or that code that seem obvious to me right now, but there's no guarantee that that'll be obvious to me 2 months later. And if it's not obvious to me 2 months later, it certainly isn't going to be obvious to anyone else. And so admitting that when I come back to this code in a number of months, I will have forgotten means that I'm going to pay more attention to how I name my identifiers. And it's going to lead me to create better documentation, whether that be comments or a wiki or whatever. When I'm willing to admit that others might know more than me, that leads me to a lot of productive things as well. I'm willing to use better solutions. We live in a world where there are millions of software libraries. If I'm a JavaScript developer, there are thousands of good NPM packages out there and millions of bad ones, but thousands of good ones. And so when I'm willing to listen to the advice from other people that maybe have experience with one of these, I come up with better solutions. Process is something that's always evolving too. When I first came into this industry, Agile and Scrum were still very much like kind of a radical, weird, hippie idea. And now it's a very mainstream idea. But that came into the mainstream because people were willing to admit that there were better ideas out there about how software could be developed. Other attributes that come from being willing to admit that we don't know everything, including being lifelong learners and asking better questions. If I'm going to continue to grow in what I know, I need to admit that there's stuff out there that I haven't learned yet, right? That drive to continue to learn is only fostered because I'm willing to admit that there are things that I don't know. And something else that has been proven is that humility leads to asking to better questions. There was a research paper that I looked at that looked at university settings. And when professors would give lectures to their peers, the most common question askers were the most senior professors. And this wasn't them trying to toot their own horn. No, they were honestly asking questions. And the theory was that there was some combination of things that led to this, but the combination probably was there was some kind of confidence from the senior professors that they weren't afraid to look bad. And the younger professors didn't want to look like there was something they didn't know, so they didn't want to ask a question. And so there was some kind of confidence there. But the corollary is that maybe it was that willingness to ask questions, even of younger, less tenured colleagues, that helped the more experienced professors get to the level that they were at. There are a lot of things that we could talk about in terms of cognitive biases, and I've actually seen people do entire presentations on cognitive biases for software developers. But one I want to specifically focus on today is the Dunning-Kruger effect. And the Dunning-Kruger effect is a cognitive bias in which unskilled individuals suffer from illusionary superiority, mistakenly rating their ability much higher than it actually is. The idea being here that when you first are starting to learn something, you first start to get a grasp of a domain, and you feel like you know the whole thing. And as you learn more about it, you learn more about what you don't know. And so there is actually this very predictable curve in the confidence where when you first learn a little, you feel very confident. And the more experience you get, it starts to drop down. And at some point, you get enough experience that you maybe start to come back up. But for most people, that level of confidence never again reaches what it was right at the beginning. Because the more you know, the more you realize you don't know. So, this is something that is very important for us as developers to realize is when we first learn a technology, things like Svelte that are very new, right? I might spend some time at a conference like Code PaLOusa and learn about a new JavaScript framework and then play around with it for a few days. I feel like, man, I know a lot about this. But then once I really get into it, I realize that there's a lot I don't know. Maybe thinking a level of abstraction up from that, we see this a lot with design patterns. When I first started studying design patterns, I did some reading, and man, I thought that I was a genius with design patterns. And the more I used them, and in some cases misused them, the more I learned what they were really good at and where they really helped the system. I learned a lot about when not to use them. And so here I am a decade later, and in a lot of ways, I feel like I know less about design patterns now than I did 10 years ago. But part of that is just because I have learned that there's far more nuance to when to use and when to apply design patterns than I originally understood. There's a really interesting paper published by a PhD out of Duke University, a guy named Dr. Mark Leary. And he wrote a paper called The Psychology of Intellectual Humility. And one of the things that he pointed out in his summary, that he pointed out maybe as like the key thing, is that it's critical for us to remain vigilant to the possibility of being incorrect and to solicit and consider the perspectives from other informed people, especially those whose viewpoints differ from our own. Right. And so he sees this willingness to admit that I'm incorrect. That's what really starts to lead toward my learning and growth. There was another interesting book that I read called Humility is the New Smart, Rethinking Human Excellence in the Smart Machine Age. This book has some really interesting ideas, and the authors are really getting at the point of, what are skills that artificial intelligence and big data and very powerful computers are going to start to make obsolete. There was a time when knowing in your mind a lot of trivia was a very useful thing. Before the internet was broadly available, before smartphones put a supercomputer in everybody's pocket, you could look really smart by being able to remember and have memorized facts. The authors of this book are pointing out that that has kind of ended, and there are a lot of other kind of rote decision-making skills that computers and artificial intelligence will continue to make obsolete. And so one of the things that's important is the ability to learn and collaborate and innovate. And those skills, learning and innovating and collaborating, are all dependent on humility. And this is how they define humility. They said that humility is a mindset about oneself that is open-minded, self-accurate, and not about me. That enables one to embrace the world as it is in the pursuit of human excellence. So again, one of the things I like about this is that they're not saying that we need to think very lowly of ourselves. We just need to have an accurate view of ourselves. For me to be humble doesn't mean that I'm a terrible programmer. For me to be humble is to recognize that I'm a flawed programmer. And they also have this clause in here where we're saying humility is not all about me. They go on to talk about this, especially in how it relates to how we view the ideas of others. They go on to say that if we're in a design meeting and I have my idea that I'm advocating for, and one of my teammates is advocating for some other idea, I shouldn't think of it as me versus my teammate, because that's putting me in the middle of it. What I should think of it is as one idea versus another idea, and I should judge both ideas based on their relative merits, and let's pick the best idea, no matter who first proposed it. And this idea of not thinking about myself leads me to another interesting author that wrote about humility, and that's C.S. Lewis. C.S. Lewis most famously wrote the Chronicles of Narnia, but he actually wrote very broadly, not just in children's literature. And there's a quote that is often attributed to him that says, humility is not thinking less of yourself, but thinking of yourself less. And if you research this, it doesn't seem like C.S. Lewis ever quite said it this way, but this is a great sentiment. This idea of me being humble doesn't mean I think I'm a moron. It means that I'm thinking more about the needs of my users or my teammates or my customers or whoever. What C.S. Lewis definitely said is this: do not imagine that if you meet a really humble man, that he will be what most people call humble nowadays. He will not be thinking about humility. He will not be thinking about himself at all. So when I have that kind of humility, what that makes me think more about is what my teammates need. How can I be an amplifier or a force multiplier for my teammates? What can I do to help them? And when I'm more concerned about amplifying the team than about self as a team, then we are going to deliver more and better software. And also, when I am more others-oriented in my thinking, that will help me think about what my users need. I am certainly a developer that is guilty about geeking out about code. I love to really dive into the minutia of programming languages. My other talk today was all about advanced uses of the TypeScript type system, which I'm fascinated by. But I need to remember that if I have a solution that uses intersection types and union types and generics and all these things and string literals, that's fun. But the thing that really matters is how well the software that I create meets the needs of the users. I need to have that user focus. Fred Brooks famously said in his essay, The Computer Scientist as a Toolsmith, that the computer scientist is successful as his users are successful. He used the analogy to say that a swordsmith is successful whose clients die of old age. And that's the kind of attitude that we need to have with software. If my users can achieve what they need to achieve, then I've succeeded. It's not about what kind of code gimmicks did I put in my code. It's about what makes them successful. We need to be realistic about what we do as software developers. Software developers, we build tools. And those tools can really help our users do two things: work faster and know more. You could make an argument that entertainment is also in there, right? Games and whatever. But in terms of actually accomplishing work, there's just those two things. Our users can work faster and know more. So what I need to focus on as a developer is making sure that everything I do, from every line of code I write to whatever I'm doing in my CI/CD pipeline, you know, all the way through, is others focused. My friend and teammate Ashley did a great talk earlier today on accessibility, and I was really challenged because, you know, she, you know, challenged us all to think about all of our users. It's easy for me to think about the users that are like me, users that don't have vision impairment or some other kind of mobility impairment or anything. But you know, 20% of my users might have some kind of additional accessibility need. And if I'm going to help them succeed, I have to think about them. Dijkstra said it this way in his paper that we started with. He said, "We must not forget that it is not our business to make programs. It is our business to design classes of computations that will display a desired behavior." Right? This is his way of saying we need to be user-focused. So in conclusion, this is how Dijkstra ends his paper, and it's how I want to end today. He says, "We shall do a much better programming job, provided that we approach the task with a full appreciation of the tremendous difficulties, provided that we stick to modest and elegant programming languages, provided that we respect the intrinsic limitations of the human mind and approach the task as very humble programmers." All right. Before we wrap up, any questions or comments? All right. Well, that's all I've got today. Oh, Sean asked, can you want to talk on imposter syndrome? Yeah, Sean, that's really interesting. And I've seen some other people do better prepared talks, right? Because there's a lot of good research on imposter syndrome. There is this idea that what happens to a lot of us is we have that initial spike in confidence. And as we start to learn more, we start to realize how much we don't know. And so what happens is I start to feel like, oh man, there's all these things I don't know. And what I see in the people around me is what they do know. You know, I don't recognize that there are things that my teammates don't know, because when I talk to them, they talk about the things they know. I don't know about the things that are rattling around in their head. Like, oh, I don't know this. And so we all run around with all these things that, you know, we don't know. And so then we have this, like, there's this very common thing where people are running around, you know, very good developers are out there thinking like, oh man, someone's going to find out how much I don't know, and I'm going to be in trouble. They're going to know I'm a phony. And it's one of the things that the best way to deal with it is to name it. The first time I ever heard someone talk about imposter syndrome, I was like, oh man, I thought I was the only one that felt that way. And the more people you talk to and the more you get into you know, some of the research, you're like, no, this is a very common thing, and it's actually understandable. And once I understand that that this imposter syndrome is a very common thing, and that's okay, then it can stop being an inhibitor for me. So again, this idea that humility is an accurate view of oneself means that I'm very willing to admit the things I don't know, but also have confidence in the things that I do know. And so, yeah, I wish I had some links off the top of my head to some of the papers I've read on imposter syndrome. There's some really good research that's been done in that area. And if that is something that you feel like you struggle with, if there's someone out there that's like, really worried that they're gonna get caught for not knowing things, I would encourage you to go do some research on that, because it'll be very helpful for you. Yeah, good point, Sean. When we acknowledge it, we're more willing to go ask for help from others. One of the problems with imposter syndrome is that it prevents us from asking for help when we need it. If I'm worried that people are going to find out that I'm a bad programmer, like, I'm not going to go ask someone a question. They'll know what I don't know. When I approach the task with humility, then I'm willing to say, well, of course there are things I don't know. This field is far too broad for any one person to know it all. No one should expect me to know everything. And so if when I'm faced with a problem, I'm very willing to go collaborate with someone and learn from anyone that is willing to help. All right. Thanks for your encouragement. If you want to talk more about this, I did not put it in the slide deck. The easiest way to get a hold of me is on Twitter. I am at Potter Eric. I would love to chat with you. Gladly share anything with you. Hope you enjoyed this. Hope you enjoyed the conference. And I will catch you further down the road somewhere.